Now I'm making a recording in Excel about how to draw two survival curves on the same graph, similarly to the Lancet Public Health study on opioid treatments where you have multiple survival curves in the same graph. I'm going to make three different columns, three variables in Excel. First variable, age, so you just type 0, 1, enter the first couple. You click on it and you drag that down all the way until 80, so now you have 80 different years, just like the example that you did in triage. Now I'm going to program the probability that they're alive as a decreasing function of age. So if they're on the drug, they all start out alive. Age 0, age 1, 100% of them are alive. Probability of being alive is equal to 1, PR alive is 1. At age 2 or age 2, we're going to code the probability alive as a decreasing function of age, just like we did in triage with the Markov cohorts. So here you could see me write in the function, this is the same function that I used in triage for P alive that I'm programming in the probability that they're alive with the drug in Excel. So these numbers are going to match the numbers in triage for the drug column. So PR alive is going to be the probability that they're alive for each of the 80 years. So the survival curve for being on the drug is going to match the survival curve that you presented from your triage results. So once you program the probability alive as a decreasing function of age, you can see the function there, same function I used in triage, drag that function down all the way to 80, and what's going to happen as you get older, the probability alive is going to decrease. So PR alive, probability that they're alive, they're on the drug, decreases all the way to when they're 80 years old, there's a 1.6% chance. The probability that they're alive is 0.016, a 1.6% chance, less than a 2% chance that they're alive when they're on the drug at age 80. No drug, what's the probability alive going to be? So if they don't have the drug, there's less chance that they're alive than if they're on the drug, right? The drug increases the effectiveness, increases the probability that they're alive. Drug shifts the survival curve up. No drug shifts the survival curve down from drug, and I'm going to shift it down by 0.05, by 5 percentage points. And when you shift that down, you can shift them all down, so they're all 0.05 lower probability of being live without the drug than with the drug. So no drug, lower probability of being live. Drug, higher probability of being live. The difference between those two curves is always going to be 0.05, 5 percentage points difference in the probability that they're alive between the no drug group and the drug group. If you select all of these numbers, select all the numbers and select the titles, it's pretty straightforward to make a graph in Excel. You could just press insert, at least on the Mac version. The insert is probably be pretty similar on Windows, I would imagine, with more recent versions. Recommended charge is the second one there. See, the second one there just looks like the survival curve that you presented from your triage results. The blue curve, the survival probability of the drug, that's going to match your finding in triage for your survival curve. The orange curve, no drug, that's lower. So what does the drug do? The drug increases the probability that they're alive by 5 percentage points, by 0.05 on the probability scale from 0 to 1 at each age 0 to 80. Let's label the graph survival curves. We have to edit this axis here because a probability, remember, a probability always varies from 0 to 1. You cannot have a probability less than 0, and you cannot have a probability greater than 1. So make the minimum of that y-axis scale 0 and the maximum 1. Now it only goes from 0 to 1, only presents the results from 0 to 1. The no drug cohort, without the drug, that whole cohort's going to die off by about age 63. See where that orange line hits the x-axis, age 63? That's the life expectancy without the drug. With the drug, still between 1 and 2% of them are still alive at age 80, but not without the drug. Let's label the axes here. X-axis age, y-axis PR alive, probability that you're alive goes from 0 to 1. The drug shifts the probability that you're alive up, shifts the survival upwards, increases the effectiveness by 0.05 at each age. So the blue curve matches your finding from triage, and the data in the drug column, column D in Excel, matches your data in triage, and the orange column without the drug, that's where we shifted it down as a comparison or as a placebo.